Welcome back from the break. I want to send a shout out to Liberty once again and thank you so much for sponsoring the show. Guys, if you haven't done it yet, please download the Tenfold education app. Send through all your questions. We know it's prelim revision week and you guys are actually stressing. Remember to study smart and not hard. Send through all your questions and we will help you. So before the ad break, I told you we might come back and do some chemistry, find a nice, interesting organic chemistry question. Now, something that I do like about organic chemistry, there's very little surprises that the examiners can actually give us. If you know all the rules of naming and drawing, and trust me, if you know how to draw, you know how to name, there are very little surprises that you can actually get. A question like organic chemistry, you get full marks. You don't fail. It is very easy, very straight to the point, and the rules do not change. It's unlike physics where sometimes they can give you 60 degrees, 40 degrees, or it's sliding down and sliding up. With organic chemistry, the rules don't change. You just need to apply all your knowledge in the right places. So let's tackle this question. So I've got letters A to F in the table, and this represents 6 organic compounds. Now, another thing to remember, if they give you a table or a picture or a diagram or whatever, and they ask you questions based on that, please don't bring in anything that's not there. The examiner wants to see whether, even though they've given you so many, you know how to identify. I know some people actually confuse like aldehydes and ketones and carboxylic acids. The examiner wants to see whether you understand that they all belong to different homologous groups and they all have different functional groups. So if they've given you these 6, we only work with the 6. If you can't find the answer, we must try look again because the answer must be somewhere within those 6. So we're given these 6 organic molecules and all our answers are going to be based on them. What I like doing before I actually answer a question is actually scan through all of them. I see that there's an O there, there's another O there. Now, sometimes the examiner will try to confuse you drawing it like this, right? The condensed structural formula. Now, what I like to do is if you can, or if you are getting confused, redraw it. I know around the C I'm going to have 3 H's, 2 H's, 2 H's, only 1 H, and this will then give you an indication whether there is a double bond or a triple bond. And this will also give you an indication whether that O at the end actually represents an aldehyde or an alcohol. Because if the number if you've used all the number of hydrogens, of hydrogens, but you still have a space for one more hydrogen, it means we do have a double bond somewhere, or it is then an OH. So keep that in mind. Also, this just means we've got 4 carbons, we've got 8 hydrogens, we've got an O. Redraw it if you cannot see it in your head. This one is the one that we actually all used to. See that there's a double bond there. There's no oxygens there. There's another oxygen there. There's another oxygen there. Already I can pick up the functional groups in which they belong. Now let's see how the examiner has structured these questions. 2.1 says, write down the letter. Please don't go and name it. Just write down the letter that represents each of the following. The first one is a hydrocarbon. Remember, hydrocarbons are molecules that are only made up with carbons and hydrogens. There's no other molecules. So let's look. Within these 6, which one only has hydrogens and carbons? This one has an O. This one's out. There's another O. There's an OH there. There's a double bond O, another O. So that one's out. There's an O, and there's nothing on this one. Already I can see hydrocarbons. These are the B is the only one that does not then have any oxygen. So that is my first answer. Just write that in. So that is, we are doing 2.1.1. Hydrocarbons, it is B. Now, you had to know what a hydrocarbon is, the same way we know all our definitions in physical sciences. That is just compounds that are only made up with hydrogens and carbons. So let's look at the next one. Which one is an alcohol? I know that an alcohol must have an OH that is bonded to it. Let's see what I have there. Let's start here. I can already see I've got an alcohol there. An alcohol is an OH. If I look at D, I'm going to have 3 carbons. I'm going to have 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. But I have an O, which means this O, if I have a hydrogen there, it's attached to one of the hydrogens. I know that an alcohol must have an OH. So E and D both have OHs attached to it. That means my answer for this one here, which is 2.1.2, it is D or E. Now, if they said only give 1, then we could have just given 1. But in this case, they did not specify. And then we're finding an ester. Remember, an ester is created or made through alcohol and a carboxylic acid, changing the name to O8 through esterification. So now let's see. Which one will have a double bond O and an O? So I can see this has a double bond O and an O. If I was to divide that in half, this side will be my carboxylic acid, and on this side would have been my alcohol. So let's see, that is the number F. So that is 2.1.3. That is number F. So let's go on to our next question. So that was just easy, 1 marks. So number 2.2 says, write down the IUPAC name of compound A and compound B. Now I want to teach you something when you are naming organic molecules. There are rules that you need to follow, and if you follow those rules, you do it perfectly fine. It's like taking a driver's license. You must do your 5-point check, fill your hooter and all that stuff. You do that fine, you pass. Exactly the same as when we are naming organic molecules. Step number 1 is to find the longest chain. Once you have found the longest chain, you must see if you have any double bonds or triple bonds, because a double bond or a triple bond must always take the smallest number, right? That's the second one. You must see what functional group it belongs to, because that will change the name ending. For an example, if we detect an alcohol, the name will end with O. Carboxylic acid will end with oic acid. Ester will end with O8, and so forth. Next one, you must find your side chains. Once you've found your side chains, make sure, final step, crucial step, that most of you guys don't remember, you need to put all your side chains in alphabetical order. Even though you have your chlorine come first and then your butane, your bromine, it doesn't matter. You must always make sure that it is in alphabetical order. Another thing that the examiner likes doing, they like to add 2 or more of the same thing as a side chain. Now in physical sciences, we have our own way of numbering. If something is 1, it's mono, but if there's 2, we say di. So we'll say dichloro. If it's 3, then it's tri. 4 is tetra. So you must always show the examiner that you also understand how we actually name in organic chemistry. And that examiners actually like that. Remember, you do get marks for correctly marking or naming the molecule. So let's look at A. A is right here at the top. So what I would always say, my darlings, is to actually redraw the whole structure, right? So if we were to draw it, let me come into this side. This is 2.2.1, just number it correctly. 2.2.1 to be. There we are. So let's see, we have 4, number A. We have 4. Let me just see if I'm naming the right one. I forgot which one they said we must name. Compound A. I've got 1, 2, 3, 4. I've got an O at the end. I've got 3 hydrogens, 2 hydrogens, 2 hydrogens, and then 1 there at the end. So let's see. So if I've got my 4 hydrogens, I know I've got 1, 2, 3, 4. The first one has got 3 hydrogens. Remember, if you do not put hydrogens around it, it does not make it an organic molecule. The second one has 2. The second one also has 2. Let me see what the third one has. This is going to be a trick. It only has 1 H and then an O. So let's see. I can only have 1 H and then I can have an O, which means this must be a double bond O. How do I know that? Remember, for carbon, it must always have 4 lines around it. 1, 2, 3, 4. Each line represents 2 electrons. When we look at molecules, they all need to follow the octet rule, meaning the highest energy level must always have 8 electrons. It means 2, 4, 6, and 8. So if it has 4 lines around it, it means it has followed the octet rule, and then it's complete. So now let's see. How do you name organic molecules? I'm going to do this one with you. 4 carbons mean it is bute. I know that there's a double bond O at the end. So the functional group that it belongs to, it is an aldehyde, which means that the name ending will end with ol. Now we have to put everything together. And we must also indicate where the aldehyde is. I can already see it's on my first one. So I can say butanol. If there is no number, it means that it is on the first one. So it's butanol. If you had to go back and draw it, 4 is butanol, means aldehyde. There is no number indicating where it is. It means it is on the first one. So the name will be butanol. That is in how we name compound number 8. Let's see what our next question says. Here we have to name compound number B, which is this one here. I'm going to do this one here so I don't waste time. So we must first find our longest chain. This is how you find your longest chain. Let's start here. I'm always going to start where I have a double bond, because remember, your double bond must always take your lowest number. I can say 1, 2, 3, 4. Let's see another chain. 1, 2, 3, 4. Still works out the same way. Let's use 1, 2, 3, 4. Right? So my side chain constantly has the smallest number. So I'm going to use the orange, because on my second carbon, I constantly have a branch, and on my third carbon, I constantly have a side chain. So I'm going to take this off, and then this is how you then have to name. Remember, we have 4, which will mean that it's but. I know that on the first carbon, that is where my double bond is. On my second carbon, I've got a side chain. Remember, one carbon is meth. On my third carbon, I've got 2 side chains. Now remember, it means 2, it means di, but I've got 3 of the same. So I'm going to say on my third carbon, I still have meth. Now my longest chain is but, and remember, I've got a double bond there, meaning my name ending belongs to the alkenes ending. Janet mustn't kill me for spelling. My name ending will be "ene," which shows that we have a double bond. Now, if we had to put everything together, remember it must always be in alphabetical order. In this case, my side chains are all meth. So this means start with a number. On my second carbon, on my third carbon, and again on my third carbon, 3 of the same things we call tri. I say tri, but I write di. We say tri. There are 3 of what? There are 3 methyls. Methyl. But what is the longest chain? But. Does it have a double bond? Yes, on the first one. What is the functional group and what is the name ending? -ene. So it's 2.3 dimethyl but 1-ene. And that is in how you had to name it. It looks a little complicated, but as you continue preparing, you'll get it right. Step number 1, find your longest chain. Step number 2, find if you have a double or triple bond. That will change your name ending. Step number 3, check if your side chains is not more of the same thing. Step number 3, put everything together. If you've got 2 or more of the same thing, number it the way we do in organic chemistry. 2 is di, 3 is tri, and 4 is tetra. Our longest chain was but. I had to indicate that on the first one. You could have said butene and not say 1. Remember, if there is no number, it means it's on the first one. And that is then how we would have named this one. So just name the chat to make things easier. So let's look at our next question. So we've named those ones. Now it says compound C is a functional isomer of compound A. Write down the structural formula of compound C. So now isomers are molecules that have different structures, but they have the same number of hydrogens and carbon. They are talking about number A. It is a structural isomer. We must write the functional name. We must write down the structural formula for then compound C. Now remember, if you had to draw compound C, the easiest thing would be, I've got 4 hydrogens, 4 carbons, I've got 8 hydrogens around it, and I have then an O. So without wasting time, I've shown you how to do it. If you are still getting confused, please draw it so that I know that you're getting it right. So this is 2.3. The functional isomer would be C. C, remember, I do have 4 hydrogens. I've got 8 hydrogens around it. Remember, it is a functional isomer, so that will be an O. It does not make it an organic molecule if you do not have the hydrogens around it. Remember, you do not want to be penalized. And then that is then how my molecule C will then look. If you are getting confused, my darlings, go and draw it. If you cannot see it with your head, draw it. Let's look at another question. So compound D is used as one of the reactants to prepare F. Let's see what F is. Ooh, F is this one. We've already said F is through esterification, and it is an ester. I know when I'm preparing an ester, I need an alcohol and carboxylic acid. I've already established that. Now let's see. 2.4.1 says the type of reaction that takes place to prepare number F. Just want to write down the answer. And then I want us to go a little bit into detail with that. 2.4.1, that is esterification. esterification, or you can say condensation, depending on which one your teacher is teaching you or told you about. Now, something to talk a little bit about esterification. When we talk about organic chemistry, there are different reactions that can actually take place. We can have hydrogenation, halogenation, dehydrohalogenation, and so forth. And we know when all these reactions are happening, we are actually forming different molecules. So when we are preparing an ester, if we were to take an alcohol with a carboxylic acid, we will form an ester and water. Now, the nice thing with esterification is that we can actually represent it. Once you can represent it, you can then name it. Now, the examiners like spicing it up a little bit and switching the alcohol and the carboxylic acid like that, but let that not scare you. You always name your alcohol first, even though they put it on the other side, and even though your alcohol has the longest chain. So that's something to keep in mind. So let's see what the next question is saying about number F. But those are all the rules that you need to know about esterification. We must then, they tell us to name the IUPAC name of compound D. Right? So D is a compound used to prepare F. Let's give the IUPAC name of D. There we are. Let me just take this off. So let's see. I've got 3 carbons. I'm going to have 8 hydrogens, and then I'm going to have 1 oxygen around it. I know that 3 is prop. Let's see. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. But I do know that I have an O, so I'm going to have an OH that is attached, the one of the oxygens that is going to be attached to the hydrogen. Remember, if we had to name it, they say name. My longest chain is 3. 3 is prop. I do not have any side chains or anything. I do know that my alcohol is sitting on my first one, so I can indicate that by my first one. So I can say propan 1 all, and that is then how we are going to name it. Let me just write it here. That's how we're going to name it. This is 2.4.2. Compound C is propan 1 all. Remember, it is the alcohol that is then required, 2.4.3. Let's look what this question has. Now they're asking us the structural formula of the other organic reactant that is used. Now let's see here. I have 1, 2, 3. Just want to take this off because we're working with number F. If I was to split this in half, my alcohol will be the one with an O, alcohol. 1, 2, 3, that was my propanol. On this side, I've got 1, 2, 3, 4. So now I have my carboxylic acid on this side. I must draw the structural formula. So remember, my hydrogens are up. I've got my double bond O and then my OH on this side. So this is right before it actually came together. I've got 4 carbons. I'm going to have a double bond O with an OH on the side. I'm going to have an H and then an H on this side. Remember, if it does not have hydrogens, it does not make it an organic molecule. You will be penalized. So this is the other one. So I have butanoic acid that actually reacted with propan 1 all, and then that is then how we got our ester. Let's look at our other form or other equation. Now they're telling us we must give the IUPAC name of F. So remember, you always name your alcohol first. Let me keep that there. This is my carboxylic acid. So I know that this was propyl 1 all, propan 1 all. And on this side, I have butanoic acid, You always name your alcohol first, and remember the name ending will change. So I'm going to have propyl and butanoate, 1008. Why does the name change? Because the OH shows that it belongs to an ester, and then the prop shows that it's my alcohol in combination with my carboxylic acid, which is my butanoic acid, which changed to butanoate. And this is then how we will name this one. And this was for 2 marks, and the whole question was actually for out of 16 marks. But as you can see, I continuously use the same rules for all the time when I had to name, when I had to draw, when I had to identify. In organic chemistry, there's not a lot of rules that can actually change. You just need to know how to take it on. Remember, guys, in order to master this, you need to practice. Go through your textbook as well as all your definitions. It's an easy topic. You cannot fail it. I wish you all the best for your revision, guys. Take it slow, study smart, and not hard. I'll see you next week.